Welcome back, everyone. Over the last few videos, we have been looking at delegates, starting out with a very generic overview of what delegates are, going from there into some examples. Now we're going to shift our attention over to events, but in all actuality, we're still continuing our discussion on delegates because, as you're going to find out, delegates are the backbone of events. So this is just where things are going to become a bit more specialized when dealing with delegates.
Exactly. The idea of events actually standardizes the use of a delegate when you're using it in a callback style scenario from within a class.
Okay.
More specifically, an event gives you added control over how a delegate is accessed from outside of a class.
Why is that important?
Well, if you remember back to the callback test example where we had created an actor class, assigned a delegate as a field, and used that delegate to give callback functionality, you'll note that we essentially subscribed to that delegate to simply listen in and see when it happened.
Okay.
Now, the way we had done that, of course, worked just fine. There were no issues in using it that way. But leaving the delegate open as a public field actually gives a little bit too much access for that scenario. Because if you think about it, that delegate being publicly accessible means that anyone can look into it, invoke it, or look at all of its properties.
Gotcha.
And if you're setting up a callback or listening scenario, you might not want the entire outside world to go in and muck with your delegate. You might want to have more control so that you can give, or so you can specify invocation restrictions such that only the inside of the class can invoke the delegate. Everyone in the outside world can only listen in. They can't change the behavior of the delegate, and they can't invoke it themselves.
Okay, so definitely a nice restriction being placed on the delegate itself.
And the implications are a little bit more far-reaching than that, though that is going to be the focus that we're interested in. That's the way we'll need to use them from within Spacefighter. I do want to point out that there are other properties that come along with accessors, or excuse me, with events, and those are things such as accessors, uses and interfaces, and interoperability. Accessors give you the ability to actually listen in and see when subscribers add or remove themselves to the event. Use and interfaces, I'm not even going to divulge into here because that would beg for a discussion on interfaces themselves. And an example of extended interoperability is, say, for example, something as such as a comm server.
Okay.
Now, again, I'm just pointing those out to note that there is more than just the invocation restriction when you're using events, but it's only the invocation restriction that we're really interested in here for Spacefighter.
Okay.
Now, to get started, what I'm going to do in this video is I'm actually going to go back to that original callback test project, and I'm going to demonstrate changing the raw delegate over to an event and show all the implications that come with it. So let's go ahead and switch over to Visual Studio and get started. As you can see here, we have the original callback test project that we created in the delegates lesson. And the first thing that I want to do here is actually switch over to the actor class and take a look at our callback delegate that we assigned here in the field named callback. And this will give us a moment to briefly discuss syntax. Since, again, an event is used with a delegate that is a field member, really you can kind of look at the event as far as syntactical use as simply being a modifier. Because where we're already exposing it as public, the event itself is specified with the event keyword. So we say public event, then give the type of the delegate, and then the name of the field.
Very nice.
Now, by specifying this event, and leaving the functionality as is, since we already have a callback scenario in place, we can actually build and run the application immediately, and there is no visual difference in what happens. Now, what I do want to point out is the invocation restriction. Since we have not done anything that would violate the invocation restriction, we're invoking from inside the class, we're not actually seeing any difference. So what I'm going to do is actually pull this back off and show what can happen with the delegate from outside. So if we leave this in its original state and move down to our load content method where we are actually listening to that callback, if we take a closer look at it, look at callback, we can see that we're completely free to invoke it. As a matter of fact, we have to send an actor, so I'll simply specify this instance of ball. Now note what happens here. As soon as running it, we actually get an extra sphere that spawns and moves in a downward direction. really random. But you can see that extra third circle is spawned in immediately.
Right there from the beginning, yeah.
So this means from anywhere external to ball, we can invoke that at will. And we can do more than just that. If we look at the properties of the delegate, we can see that there are several methods, including invoking and actually grabbing a copy of the invocation list. So really we have complete access to that as though callback were a local variable or anything else we had full access to. Let's take a look at what would happen if we change this back over to an event. And we'll build, make sure that that change is taken into account. Now if we look at ball's callback, we can still see it here, meaning we can still assign to it. But if we take callback and try to look into it further, or even invoke it, we see that we're not presented with the hint as to whether or not we can send in an actor. And if we try to build, we'll notice that that is now a compile error. It's saying here that the event actor.callback can only appear on the left-hand side of subscribing or unsubscribing. We can't access or we can't invoke it except for anywhere inside of actor itself. Also, if we try to look at any of its members, we simply can't see them. If we try to type in something like invoke, once again we have absolutely no access to the event whatsoever except for subscribing and unsubscribing.
So externally, of the class in which the event is declared, the only thing we can do is subscribe to it or unsubscribe from it.
Exactly, and that makes it much easier to control what is happening with that delegate, because we know that anyone external to us is notified by us. They can't turn the scenario on its head and invoke the delegate themselves.
Gotcha.
All right, moving on from here. One thing I would like to do with this callback now is I do kind of have a naming convention that I like to follow when I use callback style events, and that is to actually name the callback based on what the function is that it's doing. For example, in a timer, I often call the actual hit or fire event just fire. In the scenario of a sprite that has an animation loop, and I want to have an event listen for a loop style event, I'll just name it loop. In this case, what is the ball doing on this callback event? Well, this callback event is actually tied to the ball's bouncing action. So what I'm going to do is actually rename callback to bounce. Again, obviously there's no actual functional implications in doing that. It's just easier to read now, as we can see, well, what are we doing? Okay, well, subscribing to a ball's bounce. So immediately you think, well, okay, now we know what's going to happen.
Right, and the delegate itself is still of type callback delegate.
Exactly. We haven't changed that part of it. Callback delegate just refers to the name here in the callback. And really, a better name for this would actually be something like actor event handler. So let me to give an example of that, because this implies that we're going to be working with actor, which follows immediately by the fact that we're sending an actor to it. And the fact that it's being an event handler means that outside of here, well, the code subscribing to this should handle what happens when this event is spawned from the actor.
Okay.
One other thing I'd like to point out really quick is that the IDE will actually be a little bit more helpful to you if it notices that the field in question is an event when you're going to subscribe to it. To show this, if we look at ball's bounce event and went to subscribe, you know, the moment I finish typing the subscribe operator, we're presented with the option to give a new actor event handler. If we hit tab to insert that, we jump over to the name of this, so we're able to specify whatever name we would like for it. And if we would also like a brand new handler to go with this, we could hit tab one more time, and it will actually drop that handler in place.
Very nice.
So to give an example of this working with this actual handler, we could take sender's color and set it to black, and then I'll comment out, actually I don't have to comment the spawn one. There will be a lot of other things spawned from it, but we should see the original gold circle turn into black when it hits the wall. And black is not something that exists on its own. That's actually found within the color, so color.black. If we watch the gold circle, it changes to black as it goes about spawning more circles.
Nice.
So once again, that was a very quick way of dropping an event handler in place, as I only had to hit the tab key twice to get all of this code. All right. There is one more thing I want to talk about, and that is the built-in event handler delegate. We kind of hinted to the idea of event handler when we made our own here, but there is actually a built-in type, a delegate, called event handler that takes in a standard set of parameters. As a matter of fact, let's go down here to our event and change its type over to just event handler. And you can see event handler exists here. As a matter of fact, with event handler, we could actually jump to its definition, noting that it is inside the system namespace. And we can see that it is meant to take in an object and an event args parameter.
And of course, it's just a delegate.
And this, you may have seen things like this if you worked in Windows form programming, because you'll have things like a mouse click, which will come along with sender and mouse event args. It's still event args, it has just been subclassed from event args. The reason I'm pointing all of this out is this is actually the protocol that I'm going to be following for a certain subsystem inside of Spacefighter. I'm actually going to subclass event args myself once we get to that point. But I did want to show this in action because, one, it is a largely followed standard, and two, I'm going to be using it inside of Spacefighter. So if we wanted to change our code over to start using that standard by using the built-in event handler, there are a few things we'll have to change. Of course, since we have a lot of handlers set up to handle methods with this signature, all of those methods will have to be updated. Also, since we need access to actors, we'll actually have to cast back from object to actor. Also, just to show that this delegate is now out of use, I can go ahead and comment it out. If I build, expect a lot of errors because we suddenly changed the method signature, as we saw when we were looking at event handler. So if we build, yes, there are indeed many errors, and that's because, one, this type actor event handler no longer exists, and all of these methods are going to have the wrong signature. To change them to have the right signature, we actually need to change this over to object sender and pass in an event args argument or parameter. And for the sake of speed, I'm going to copy this method signature to all three of our bounce handlers. The moment I build now, our sender is now invalid because he is just a standard object. He's not an actor. Now, from here, a good rule of thumb is to check this as you're casting it, to not just blindly accept that it is the known type. Though I am actually going to do that, just to get these working as quickly as possible, I'm going to make an actor local variable. And I'm going to set that equal to sender casted to actor. Of course, there's many options here. You could cast using the as operator and then check to see if that actor is null or not before using it. But here, for the sake of time, since we control both sides of the equation, we have just gotten done writing actor, I'm going to use it directly, really just to save time. And we'll paste in this new actor definition here, though now the name actor is different from sender, so we need to paste that in. So actor goes over sender, and let's see a few more places down in our code here. Now, whenever we go to subscribe to our bounce, since bounce is of course event handler, it's actually the event handler type that we need to instantiate. So we'll drop this back, and there is one more location up here in bounce spawn. If we bring all these back to event handler and build, we have, what have we missed? Bounce spawn. And, oh, ball bounce, this was color.black. Oh, this is the one we made from texture. I'm just going to wipe this one out entirely. Again, this is the event handler I made just to demonstrate the ID's use of event. And process bounce. Okay, one last place we need to update. Remember that in actor we're actually calling the delegate, and our method signature takes only one actor. We actually need to give an event args. But in this case, if we're following the standard and we don't want to pass anything, none of our methods are meant to take in any arguments whatsoever, well, there is a built-in type in event args called empty. So we can pass in event args.empty if we would like a convenient empty result to be sent. So now we can see that all of our errors are in fact gone, and we can run, and the behavior should be back to the way it was originally. We have the cascading style bouncing circles. So again, a bit of effort, but that's only because we have retroactively applied the standard formed in the event handler built-in type.
Very
But again,
nice.
I just wanted to show that, and it's good to walk through it a few times because I do want to stress the fact that that's how it works. You have an object sender and you have event args, because that is used so widely in code. And let's see, with that, really, I think that is everything that I wanted to show in this video. Again, this is just to get everyone up to speed with what an event is and the implications with invocation restriction, why that is good for us, and the added control from within a class, and some of the implications of using it both in the IDE and using the built-in event handler type.
Okay, that sounds good. And we'll be moving from this video into another video where we start taking a look at some event examples. And as Logan has already said, we'll be using events in Spacefighter. So with that, that is going to wrap up this extension of the delegates conversation or discussion and our quick introduction to events. Thanks a lot.